Welcome to Velocity User Training. This session is intended for anyone who may use Velocity, admins and managers included. We will cover these topics from the perspective of a non-admin Velocity user. We'll be working in a Velocity instance set up with inventory and tests simulating an environment you might find in any network lab. We have automated tests and a Layer 2 switching infrastructure that prevents the need for us to log into any devices or do any physical setup when configuring a test bed. And of course, the whole lab is managed by Velocity. Here is the first of 3 use cases for this session. We'll be running our new hardware test plan on our new router release candidate. Our test plan is very simple, consisting of just 2 basic tests. The first just connects to a router, enables and disables a port, and verifies the CLI output. The test is already defined and automated, so all we need to do is set up the test bed, run the test, and check the results. This use case will introduce us to Velocity resources, topologies, reservations, automation assets, and the activity catalog. The router we're testing is represented in Velocity inventory as a resource. Resources contain a number of properties to store things like their IP address and rack location. Ports can be defined to track connections to other devices. These can have their own properties, like port speed. Sessions can be defined for a resource to allow users to connect to a device from Velocity or run automated actions. Drivers are automated scripts that perform actions like health checks and configuration changes, and agent requirements can be set to make sure drivers are run from the correct systems. Nested resources can be configured to handle modular resources like chassis with removable cards. All resources inherit from a resource template, which defines each of these items. Admins are responsible for creating and maintaining resources and device templates. Each device can have a number of ports arranged into port groups. Just like resources, ports can have properties and are built from a template. Port properties and status can be auto-populated by the device's driver as well. Velocity keeps track of physical connections between ports, including connections to a Layer 1 or Layer 2 switch used to create dynamic connections between other resources. Velocity keeps track of physical connections between resources. This includes connections to Layer 1 and Layer 2 infrastructure. Let's take a look at resources and connections in our Velocity environment. We'll start by navigating to the Resources page using the menu bar at the top of the screen. Click on Inventory, then Resources. You'll see a list of all the resources we are managing in Velocity. On the left side, you'll see the search functions. You can use the search bar to search for any resource by name, but you can also search for any field, property, or port within a resource as well. These fields allow us to filter based on availability, status, whether the resource is nested, and by resource group. Resources can be grouped into folders and subfolders, and you can navigate those here. Let's narrow down the list and find our ANR 4020 router. This is the router I'll be using in my examples. I'll click on the resource's name, and we'll see the resource's ports listed. Ports can be grouped in any way an admin chooses, and here we see them grouped by the card slot on the router. I'll click on Properties on the resource's menu bar, and we'll see the properties stored for our router. Going back to the port list, we see that some ports are listed as being connected to ports on other devices. We can see a complete list of connections in our lab by clicking Inventory on the top menu bar, then Physical Connections. A topology is defined as a collection of resources and the connections between them. It is a convenient way to define a test bed and reserve all the devices you need at once. Here we see a simple topology of 3 resources with the ports and connections relevant to a particular use case defined. Resources and ports in a topology can be named for readability, and so automation scripts can identify them easily. Topologies can also be used to set up dynamic Layer 1 and Layer 2 test beds, enable features like automated actions and interactive sessions, and trigger manual cabling work orders. We'll get into these features later. Connections defined in topologies can represent direct physical connections between 2 devices, dynamic connections made through L1 or L2 switches, or even connections that can be created by manual cabling. If a connection defined in a topology is not possible, you will see an error message at reservation time. Let's take a look at a simple topology. To find our lab's topologies, click Library in the top menu bar, then Topologies. You'll see available topologies listed. On the left side, we have search and filter functions similar to the resources page and throughout Velocity. Let's open our 4020 testbed topology. We have 4 resources in this topology, each with connections to other resources. The content server is used in this testbed to store files used in traffic and quality of service testing scenarios. In the center, we have our device under test, the A&R 4020 router. If you click on it, you'll see the pane on the left side display properties like its IP address and online status. Towards the bottom of the pane, there is a list of properties called System Identification. We saw these on the resource view in the last demo. If I expand this, you'll see the properties listed out. Clicking the Ports tab displays the resource's ports that are included in the topology. Notice that all the resource's ports are not listed, and one has been given a label. The other 2 resources in our topology are test gear. The Spirent Test Center is used for traffic testing, and CyberFlood is used for security testing. Abstract topologies allow you to reserve a group of resources that match certain conditions. If a connection is defined, this includes the ability to create that connection. Here you can see an abstract traffic generator device. Its conditions are set to find any device that uses the Spirent Test Center template and has a property named version set to 5.4. When the topology is reserved, Velocity will find an available resource that matches the listed conditions. This includes connections shown in the topology, so the chosen device will need to have a way to connect to the 2 logical devices shown. Abstract topologies will have a different icon on the topologies page. Any topology that contains an abstract resource or condition is considered an abstract topology. Velocity can track connections to your L1 and L2 switches. If you create a topology that depends on these connections, an L1 or L2 driver will create the connections when the topology is reserved. The switches and connections are transparent to the topology, meaning you don't have to specify the switch used to connect your devices. Velocity also supports a manual cabling workflow. Port groups can be designated as adjacent, meaning a new manual connection can be made between them. Topologies with these connections configured will generate a work order detailing how to cable the desired configuration. Reservations requiring manual cabling cannot be scheduled to start immediately, and the reservation will only start at its scheduled time if the work order is marked as complete. Topologies and single resources can be reserved in Velocity. To see existing reservations, click the Schedule tab and navigate to the Reservations list page, shown here, or the reservation calendar, shown here. You can create a new reservation from these pages and from many other places, including topologies and resources pages. Let's take a look at the new reservation page. Your reservation's name will be seen by other users, so make sure it's descriptive. Including a short description is also helpful. Reservations can be scheduled to start immediately or at a future time and can be configured to repeat. If you have the resource queuing feature enabled, you'll be able to automatically add the reservation to the queue if there is a conflict. You can add automated tasks to a reservation to be performed during startup or teardown. Click Add New Task and choose from the list of available automation assets. Startup tasks will be run during reservation's activation phase at the scheduled start time. Teardown tasks are configured to be run at a specified number of minutes before the scheduled end time. These will be run in addition to any mandatory tasks configured by the admin. From the Invitations tab, you can invite other users to your reservation to allow them to do things like run automations and access interactive sessions within the reservation. Invited users will receive an email invitation. From the Permissions tab, you can select other users to share your reservation with. These users will have full permissions. You can also designate a new owner for the reservation. Reservations can be shared or exclusive. This allows a user to block off an entire resource, share an entire resource, or only block off some parts of a resource. If you have a large modular router, for example, you can start a shared reservation on the entire chassis and start an exclusive reservation on just the card or ports you need. Other users will be able to start new shared reservations on the chassis and create exclusive reservations for other components. If you try to reserve a resource during a time it is already reserved, you'll see a conflict menu. You'll have the option to choose other resources or choose an available time. If conflict resolution is configured, you'll have the option to escalate the conflict. Users designated as conflict resolution managers will be notified and can resolve the conflict by choosing which reservation will get priority. If your system has the resource queuing feature enabled, you'll see an option to add the reservation to the queue. Resource queuing is an optional feature that allows reservations to be queued when there is a scheduling conflict. If a reservation is queued, the entire reservation will be activated once all the resources are available. This only applies to reservations that are set to start immediately. It also allows high-value resources to be shared between multiple active reservations and only activated when needed. Set resolving time on a resource in a topology as deferred, and it will not be reserved with the rest of the resources when the reservation starts. When the resource is needed, it can be activated and then released when it is no longer needed. Let's reserve our topology so we can do some work in the testbed. Our goal now is to run some regression tests against a release candidate software load. You can click the Reserve button right here from the topology view, or you can return to the list of topologies and click the clock icon on the topology you choose. The new reservation page will open. First, we'll want to name our reservation. We'll name this one after the task we're doing, 4020 RC testing. We'll add a description too. We'll leave the schedule at its default settings to reserve the topology for an hour starting now. Clicking the Resources tab on the Reservations menu bar shows us a list of the resources and ports to be reserved. We see some abstract devices listed, and we can modify the conditions used to select those. We'll get into how to do that in a later section. We know we need exclusive use of the router for the type of testing we're planning, so we'll change the sharing setting to exclusive. Some of the devices give us the ability to set a configuration and software image when the reservation starts. Everything should be on the correct version, so we'll leave those alone this time. I'll click Submit and we'll see Velocity create the reservation. Here we see it activating as Velocity sets up our testbed. This includes determining which resources and connections are chosen to resolve the conditions of the abstract resources in our topology, and configuring any Layer 1 or Layer 2 devices needed to make dynamic connections. If we were running any startup tasks or configuring any of the resources in the topology, that would be done now too. Now the reservation is active, meaning our testbed is configured. We're ready to do any manual work we need to do or run our automated tests. Velocity can run automation in the form of iTest test cases, Python scripts, and Bash scripts. You can find all available automation assets under the Library tab. Automation assets can be run with or without a topology, but if you need to interact with a device, topologies make it much easier and lends your script to being more portable. When a topology is used, automation assets can access info like device properties and port names. If device sessions are configured in the topology, scripts can use those as well. You can also assign labels to devices in a topology that describe their function within the testbed, such as traffic generator or DUT. This allows your script to query a device based on its role without knowing any specific device info beforehand. All these features combine to make writing a portable script that can be used across a wide range of testbeds and devices much easier. Tests also accept input in the form of parameters. These may be used to alter how the test behaves. You can set default parameters and use parameter files. Defaults can be overridden when scheduling the test, and ad hoc parameters can be added. You can use parameters to input environment info, but most of the time, it's best practice to store all environment information in the topology. Velocity agents execute automation assets and drivers and deliver the results to Velocity for creating execution results reports. The Velocity VM provides some agent processes used for executing drivers. Additional agents may be installed on other hosts and can be distributed throughout your lab environment. If no compatible agents are available when an execution is scheduled, it will be queued. Agents advertise their capabilities, like the scripting languages they support and software packages available to them, so that automation assets with special requirements will be run from the right agents. Agents can also be restricted to configurable pools so that you can guarantee availability for certain uses. Some features, like drivers, require their own pool of agents. You can see available agents by clicking Reports in the top menu bar, then Velocity Agents. The gray status light means that an agent is disabled. Green means online, yellow in use, and red offline. Our active agents are split between an external server and the Velocity VM itself. We can see some agents are restricted to pools, like this one, which is reserved for triggered tasks. The capabilities list tells us about the environment the agent is running on and what script languages it supports. Let's look back at our 4020 regression testbed topology. We can see our 4020 router has been given a label of DUT. On the left pane, we see the inventory name property has the value of ANR-4020, which is the name of the resource in Velocity's inventory. One of the ports has a label of DUT_port. These labels will be used by the script to identify the Velocity resources so it can query the associated properties and connect to the configured sessions. In our case, the iTest test case we're about to run will connect to our DUT using the telnet session configured to the router, and it will query Velocity for the device's IP address and the name of the port we have labeled as DUT port. To run our automated test, we'll click Library in the top menu bar, then Automation Assets. I'll use the folder structure in the left pane to find my project containing the test case file, in this case called AI Router Regression. I'll click the Run button on the port admin test case, and we'll see the options we have for a test execution. By default, Velocity will produce reports that display all execution messages for a script and include more detailed information for steps that cause errors. You can change this behavior to show more or less in the drop-down menu. You can schedule the test to run at some time in the future or immediately. On the Topology tab, I'll choose our 4020 regression testbed, and because we already have a reservation, I'll uncheck the Auto Reserve box and choose the active reservation we made in the last demo. This test case requires a parameter. You can enter the value manually, or choose a parameter file from the list. I'll find the parameter file with the correct value and click Run. You'll see your reservation queued as it waits for an available agent and creates a reservation if needed. Execution reports are stored in Velocity's database and can be filtered by date, test case, and asset type. All executions generate reports, including drivers and tasks. Reports can be exported to create bug reports or to be shared outside of Velocity. Looking back at the results page for our test case, we can see that our latest execution is finished and the test passed. Let's look at the test report for more info. We can see the execution status, the topology used, and other details. Scrolling down, we'll see execution messages generated by the test case, giving us info on what the script was testing and how the result was determined. To print or export the report, click the Print Report button near the top of the page. You can create custom templates to change the format or how results are displayed, but we'll use the default template. The report will load in another format containing the same info. This template creates an HTML page that you can download. You can group automation assets in a run list and execute them in sequence. The topology is set for the entire run list. Parameters and agent requirements can be set for the entire run list or per test case. The activity catalog displays task-oriented activities that simplify common tasks. Activities may contain Velocity objects like test cases and topologies along with task buttons to do things like start reservations and test executions. Multiple tasks and test cases can be included to make multi-step processes quick and easy. Activity pages support formatted text and images so rich tutorials and instructions can accompany these tasks. Activities can only be created and configured by system admins. We have an activity catalog set up to run the same test we saw in the last demo. Find the Activity Catalogs page by clicking Library in the top menu bar, then Activity Catalog. We have one catalog called Router Port Admin Test. When I click on it, we can see some documentation explaining the test case. This section can display anything an admin chooses, including images. Below that, we see two topologies that are associated with the catalog. I'll click the Reserve button and Velocity will reserve the topology and show me a list of automation I can choose to run. In this case, we've only configured the catalog to display one test case. I'll choose it and click Run. If I click Run with options, we'll see the execution configuration pages we used in the last demo, where we can do things like modify parameters. I'll refresh the page to check the status of the test run, and I see that it's complete. Clicking this link will take us to the test report. We've completed our first test. Now for the second. Our second test is a simple one-way traffic test. The topology we need for this isn't made yet, so this use case will introduce us to how to create static, dynamic, and abstract topologies. The test is already automated, so we'll want to make sure that we build the topology in a way that's compatible with the existing script. Everything we've done up to this point can be done by a user with the lowest level permissions. When a user logs in for the first time, their username is added to the list of all users. An admin can then enable them and optionally add them to a user group. User groups can be granted access to one or more resource groups. This allows them to view and reserve resources in that group as we have been doing throughout the session. Our resources belong to a resource group called QA testing. Resources outside of a resource group will be visible to all users. Admins can create, modify, and delete resources. System admins can do this across the entire system. Resource group admins can do this within their resource group. Users that are granted the correct permissions and system admins can create, modify, and delete topologies. This is set on the user group level. Our user group has that ability, and we will need it for our next use case. All users can make changes to a topology and reserve it, but users without edit permissions can't save the changes. A user will not be able to see a topology if it contains any resources they do not have permissions for. By default, new topologies can be edited only by the user that created them, but sharing can be enabled. This is the topology editor view with a new blank topology. The main area is called the canvas. This area on the right lists resources and other objects that can be added to a topology. Drag and drop to the canvas to add. Click the Connect button or drag lines from one device to another to create connections between devices. If a connection isn't possible, an error will be shown. Click the drop-down button next to Save to name the topology and toggle Draft Status. As I mentioned earlier, automation can use velocity topologies to get info about the testbed it's running in. This makes it very easy to manage things like IP addresses, login credentials, and port names, and to make automation work across many environments. Automation can identify devices and ports using names that we assign when building the topology. These names should describe the function the device or port has in the test. Remember, the purpose is to make the automation work with different devices. Our resources all have names already in Velocity. We call those inventory names in this context. When you add a resource to a topology, we will only see one name. Once you give the device a new name, you'll see both. Automation can get the values of resource properties like the ones shown here via itest commands or API calls and other scripts. Port names are similar, but the inventory name is called port number. Work with the automation's authors to know which names are needed in the topologies and which properties will be referenced. Now, we'll create a topology to support our traffic test use case. It'll have dynamic layer 2 connections and an abstract resource. Navigate to the topologies page and click Add. The right side of the editor has a panel containing the items you can add to the topology canvas. The topmost button represents resources kept in Velocity's inventory. I'll click there and use the search bar to find my 4023 router. Then I can drag and drop it onto the canvas. This will be our device under test, and our scripts will need to query Velocity to get info on it. I know the script is expecting the resource to be labeled DUT, so I'll set that label here. Next, we need to add a traffic generator. We don't care which one of our three is selected, so long as it is available and able to connect to our DUT through our layer 2 switches. We'll create an abstract Spirent Test Center by adding the Spirent Test Center template to the canvas. The second button in the panel contains abstract resources and templates. I'll click there and search for my Test Center template, then drag and drop it to the canvas. When the topology is reserved, Velocity will choose any available resource that uses this template. I'll add a port to this device so we can configure a connection between the traffic generator and our router. I'll name it based on what the script expects, and set its template to the basic network port template. Now, to connect the two resources, I'll click this button on the traffic generator. When the connection editor appears, I'll find the port on the router I'd like to connect to and drag it here to create the connection. I know this connection will be through a layer 2 switch, so I change the link type to VLAN. I'll need to label the port on the router to work with the automated test as well. Now I'm ready to save the topology. Click the drop-down menu button next to the Save button to change the name. New topologies are always named New Topology and marked as Draft. Draft topologies can't be reserved. We'll uncheck that and name our topology and click Save. We're not ready to run our traffic test just yet. One of our router's new features is support for 10 gig ports. Our traffic generators have a mix of 10 gig and 1 gig ports, so we need to make sure our abstract topology chooses the 10 gig. We can do that with conditional language. Conditional language lets you set requirements for how abstract resources will be resolved. Common uses include specifying a device's model number or software version. See the conditional language guide on Spirent's support site for complete documentation. Let's modify our topology to make sure we'll reserve 10 gig ports on our traffic generator. Our topology is still on the screen, so I'll click the Edit button. Then I'll select the traffic generator resource and open the Ports menu on the left side of the screen. Selecting the traffic port and clicking the pencil icon allows me to make changes. I'll change the port definition to Custom and enter conditional language that ensures a 10 gig port is chosen. I'll save my changes and then save the topology, and we'll be ready to reserve it and run our test. To run the test, I'll navigate to the Automation Assets page and find my traffictest.fftc test case file. I'll pick the topology I just created and leave it set to auto-reserve. The parameter here sets the pass-fail threshold for throughput. We expect traffic to stay at 90% of the line rate throughout the test, so we'll leave it at 9,000 Mbps. I'll click Run and the test will queue. The reservation is being created, the Layer 2 connections configured, and an agent selected for execution. We'll wait for the test to run, and we can see that it failed. Scrolling down, the execution messages tell me that the test failed because the throughput was lower than expected. Because our test failed, we need to determine why. We'll need to connect to our DUT manually and do some troubleshooting. We've been running automated scripts against devices and topologies that involve connecting to those devices and issuing commands. How does the test script know how to log in and communicate with the device? That info is stored in device sessions. Sessions contain basic information like which protocol to use and the device's IP, ports, and credentials, usually by referencing resource properties. Crucially for CLI automation, they contain prompt information. This tells our scripts what strings to look for before issuing a command. If you've ever written an expect script, the process is similar. Scripts will wait for text to appear that matches the stored prompt, and after an idle period, send the command. Sessions can be used by automation, as we have seen, and also as interactive sessions where users can connect to the device right from Velocity. Sessions can link to device libraries where reusable procedures can be defined for use in automation and as actions in interactive sessions. Sessions used by automation must be added from the iTest GUI. Interactive sessions must be added from the Velocity GUI. Interactive Workflow Automation, or IWA, lets you open device sessions right from an active topology. You can run manual commands and choose from a library of automated actions. Interactive sessions are captured so they can be documented for troubleshooting purposes. They can also be imported into iTest where they can be replayed or converted to quick and easy automation. Now I'm going to connect to our new 4023 router so we can verify the results of our test case and maybe start to troubleshoot. I'll reserve the test bed again and wait for the reservation to activate. Now I'll click on the Topology tab on the reservation screen and find the router resource we're testing. I'll select it and click on the Sessions button that appears. I can see there's a Telnet session configured for it, so I'll connect to that. I'll start just by doing a quick manual command to check the status of the ports and make sure that all looks correct. We can see the ports are up as expected. Now let's check the traffic counters on our port and look for errors. We could run this command manually, but we have access to the library of automated procedures used by our automated test. These are called quick calls. In the Quick Calls menu, I see we have a few to choose from. Get Interface Traffic Status will give us the info we want. I'll enter the name of the port we want to view and click Run. We can see some traffic coming across, but it's not reaching our 90% threshold. We don't see any errors or drop frames. We'll need to pass this info along to the dev team to investigate further. We can see the history of our session here on the right side of the session window, and you can copy the responses to create a bug report. You could also share a link to the reservation with the dev team, and they'll be able to see your complete session in the Capture tab. They'll be able to see all the commands you ran and the complete responses from the device. Captured sessions are also available in iTest. Here on the Capture view, we can switch our data source to remote and we'll see all the sessions from Velocity. We can move these to a test case and easily replay them, or use them to build more quick calls to be reused in other automated tests and in future Velocity sessions. That concludes Velocity user training. If you will need to manage or configure Velocity or a resource group, be sure to check out the admin training videos.